Good morning, everyone. I'm Dr. Preeti Sharma, Professor, Department of Biochemistry, Santosh Medical College. Today, I'm going to talk on one of the very important topic of biochemistry, that is xenobiotics metabolism. If you want to understand the concept of health and diseases, you will have to have knowledge about what are the xenobiotics and how they are being treated by the body and how they become convertible to some form so that they can easily be excreted out of the body. So there are so many things are to be taken into consideration before having understanding the proper knowledge about what is the link between the xenobiotics and scope of xenobiotics in health and diseases. So let's have a look on to the various slides about the xenobiotics and their metabolism. So I'm going to share the slides here. If the screen is visible to everyone. Okay. So xenobiotics metabolism. Let us have first of all understanding about what are the xenobiotics. It seems to be a newer term to you because so far you could get about what are the carbohydrates, what are the proteins, fats, and what about their chemistry and metabolism. Xenobiotics is a term which relates to the compound which are foreign to the body, which we cannot synthesize in the body. These are certain substances which are foreign to our body and they are entered into the body intentionally or accidentally. So once they are entering the body treat them as a foreign and body wants to get rid of it within a minimum shortest time to be exhaled out of the body. So for that, there are certain enzyme systems available in our body which convert these xenobiotic substances into something which is more hydrophilic and easily excretable out of the body. So these are the xenobiotic substances. So let us talk on xenobiotic. A xenobiotic is a compound that is foreign to the body. Xenobiotic can produce a variety of biological effects, including pharmacological responses, toxicity, immunological responses, and cancers. Xenobiotics can be exogenous. The foreign molecules, which are not normally ingested or utilized by the organism, but they gain entry through dietary foodstuffs or in the form of certain medicines or drugs used for therapeutic cause or are inhaled through environment. For example, we can take the examples of drugs, food additives, certain pollutant, insecticides, chemical and carcinogen. So it is very apparent from the first slide that what are the xenobiotics. These are totally foreign substances. In your surrounding, you meet with a lot of substances. Few are visible, few are not visible. There are various routes to the entry of these xenobiotics through oral route, through mouth, through inhalation, through skin also. So these are the routes and through which the xenobiotic substance enter your body. So xenobiotics can be endogenous or exogenous. They are most of the time, they are exogenous. They are some certain, these are the examples in the previous slides. In these slides, I have showed you drugs, food additives, pollutants, insecticides, chemical carcinogens. These are all certain exogenous. Maximally more than 95% are exogenous substances. But besides all these, there can be certain endogenous substances though they are not foreign substances, but have effects similar to the exogenous xenobiotics. And these are synthesized in the body or are produced as metabolites of various processes in the body. We can take the example of bilirubin, bile acids, steroids, eicosanoids, and certain fatty acids. There are few bacterial products also which can be which are behaving as xenobiotic substances in the body. Now, metabolism of xenobiotics. Metabolism of xenobiotics occurs in two phases. The phase one, the major reactions involved is hydroxylation. In addition to the hydroxylation, a wide range of reactions also takes place, including the deamination, dehalogenation, desulfuration, epoxidation, peroxygenation, reduction, etc. For better understanding of their metabolic pathway, it's being the metabolism of xenobiotics is divided into two parts. One is the phase one metabolism, and the second one is the phase two metabolism. So the mainly catalyzed phase one reactions enzymes, they are mainly catalyzed by members of class of enzymes referred to as monooxygenases or mixed function oxidases or cytochrome P450. Cytochrome P450 is a superfamily of the enzymes which includes a number of families, and in every family there are a number of members. More than 20 to 200 families so far have been demarcated, and their members have also been identified and well studied in nearly more than 6 species. So other enzymes of significance are aldehyde or alcohol dehydrogenase, deaminase, esterases, amidases, and epoxide hydrolases. Then biotransformation or detoxification reactions. So nowadays, I will shortly explain to you the detoxification term is no more used, because from previous time the word has been used. So we are using this word, but nowadays the most appropriate term for expressing the metabolism of xenobiotics is biotransformation. Because something goes to your body and body is unaware of it, what it has to change, or whether it has to detoxify or it has to toxify. Its only purpose is to metabolize, and metabolism does consist of certain catabolic and anabolic phases, and purpose is to convert the molecule into the more smaller molecule which are more hydrophilic and which can easily be excretable, because nothing is stagnant in our body. Everything has to go out of the body after certain span of the time. This is the general rule of the nature. It is not only with the xenobiotics, but it is also with certain all the metabolites, like if it is the case of metabolism of carbohydrates or lipids, all of them catabolites, they convert into the simpler molecules, simpler metabolites. They have their own functions in the body, and after a certain span of time, they convert more and more simpler one, and they are removed out of the body after a certain span of time. So same is the fate of xenobiotics here. So we can appropriately call this kind of metabolism as in biotransformation. Under the biological system, under the enzymatic effect, these xenobiotic substances are converted into something which is more simpler, which is more hydrophilic, which is more polar, so that it becomes very biofriendly with the system, aqueous system, transporting system of the body, and it can easily be excreted out of the body. Could you understand the concept? What is the concept of this metabolism? Suppose you have taken here, you're working in some laboratory, you are working with benzene, simple molecule, organic molecule, which is quite hydrophobic in nature. And you inhale its smell, accidentally it reaches to your body through inhalation. It is now in the your body. So how the body is going to treat it, because it is not miscible with the aqueous system of the blood. It is quite hydrophobic and the blood is hydrophilic. So it will stay in the body. It will try to stay in the body. So in order to prevent it to stay for longer time, it is to be metabolized through cytochrome P450 system. And it will, you know, convert it into some oxidized products, some hydroxylation happens, some functionality now attached in vivo over this benzenic group. So it becomes more hydrophilic and it can easily be excreted out of the body. I'm just giving the example. So what happened in nutshell, what we'll say, like it is the planned conversion of something which becomes more hydrophilic and easily excreted out of the body. So all the biochemical reactions involved in this conversion of foreign, toxic and water insoluble molecule to non-toxic, water-soluble and excretable form is called detoxification. But sometimes it cannot be, it is a non-toxic substance. And after some biotransformation in the body, it can convert to some harmful product also. Koi aisa metabolite is being generated in course of this biotransformation, which may be toxic. So body is unaware of this. So better we can call the term biotransformation of the xenobiotics. So overall purpose of the two phases of metabolism of xenobiotics is to increase the water solubility and thus excretion from the body. In certain situations, these reactions may instead increase the toxicity of a foreign compound, and then these are called the intoxication reaction. I can give one example. I can share with you the example of methanol. What happens with methanol? Methanol as such is a non-toxic substance, but once it enters the body, it is converted under the influence of the enzymes into some formaldehyde, and formaldehyde too under the influence of certain enzyme like alcohol dehydrogenase, it converts to formaldehyde, and from formaldehyde further it converts to formic acid. Formic acid is a strong acid. It produces significant acidity to the system. It causes acidosis, and longer stay of formic acid in the body will produce the acidotic condition, which will make failure of other biochemical reactions happening in the body. Okay? So this is an example of intoxication reaction. Okay? Something which was non-toxic, after entering the body, after biotransforming, it converted into some metabolite which is toxic. So this is an example of intoxication. So xenobiotic metabolism or biotransformation may lead to the intoxication or detoxification. Both can happen. Body is unaware. Only purpose is to convert the substance into more water soluble, and so that it can easily be excreted out of the body. This used to be the aim. So biotransformation reaction, the purpose, convert the lipophilic to the hydrophilic compound. It facilitates the excretion. What can be the consequences? The changes in solubility characteristic, detoxification, and metabolic activation. So what is the role of liver? Liver is the main organ concerned with these enzymes. The cytochrome P450 enzyme system is abundantly available in the hepatocytes, liver hepatocytes. Hepatocytes contain wide variety of enzymes to process the xenobiotics. Enzymes are present in cytoplasm, endoplasmic reticulum, and to a lesser extent in other organelles. Each enzyme represents a large family of gene product. Each gene product may be induced by different xenobiotics. So, overview of the biotransformation reaction. The phase 1 reaction can limit the toxicity of a drug. Phase 1 reaction can also convert the xenobiotics from inactive to biologically active compound. In these instances, the original xenobiotics are referred to as prodrug, or if it is prodrug, what we are calling, initially it was a simple compound. Initially it was I can take one example of paracetamol. Paracetamol is as such, or we can take the example of aspirin. Aspirin is actually the acetyl salicylic acid. Aspirin is as such does not have any pharmacological activity. Aspirin में कोई भी pharmacological activity नहीं होती as such. Once you take it, it enters the body and it enters the exposed to the liver cytochrome P450 system. It undergoes certain enzymatic changes and convert to some metabolite, that is salicylic acid. And this metabolite is pharmacologically active, and this is having the analgesic effect. So it is relieving your pain. So aspirin as such is not a drug, but after biotransformation, it turns to some active drug. So it is prodrug. What term we will use for aspirin? It is a prodrug. So pro means it is not yet, but after certain changes in the body, it will convert to the active substance. Clear? Same can be the, you can use for pro-carcinogen. Pro means it is not yet carcinogen, but in the body, it will convert to some metabolite, which is having the carcinogenic activity. So that is actual carcinogen, which is produced as a consequence of biotransformation. Phase 2 conjugation reactions can convert the active product of phase 1 reactions to less active or inactive species, which are subsequently excreted in the urine or bile. In a very few cases, conjugation may actually increase the biological activity of the xenobiotics. So overall, what can be the consequences of these biotransformations of xenobiotics? Potentially toxic xenobiotic substance may turn to inactive metabolite, or sometimes the relatively harmless substance, which can convert it into something reactive and harmful substances after the metabolic activation. So it may cause detoxification as well as intoxication as well. Body is not aware of this. Its only mission is to convert the xenobiotic into something which is more hydrophilic in nature and which can easily be excreted out of the body. In the previous slide, I showed you what are the purposes. Clearly written there. More excretable, more polar conversion of any xenobiotics happens as a consequence of phase 1 and phase 2 metabolism. So this is the overview. I can take the example of a drug here. So suppose this is a drug molecule. Drug may undergo phase 1 metabolism. It may undergo either oxidation, reduction, and or hydrolysis. Any one can happen. Sometimes more than one reactions are necessary to happen to make it more hydrophilic. So it depends upon the type of scaffold present in the drug or any xenobiotic. So phase 2 metabolism, it is it can be the chance occurrence. It may not happen. So the phase 1 metabolite may undergo phase 2 metabolism or may not undergo the phase 2 metabolism. It is not a necessary phase or necessary condition to go through. It depends upon if after the phase 1 biotransformation, if the molecule or if the xenobiotic is not enough hydrophilic, then it has to undergo phase 2 metabolism. That is a conjugation reaction. The purpose of conjugation reaction is to conjugate with certain more hydrophilic adducts so that the drug or that the metabolite can easily be excreted out. Okay? So following phase 1, the drug may be activated, unchanged, or most often inactivated. Okay, so there can be various fates of xenobiotics or drugs. Some drugs directly enter the phase 2 metabolism. There can be the chances, suppose we have taken some xenobiotic or some drug which is already having some functionality. So it is already polar, something polar, but so it will skip the step. It may skip the step of phase 1 metabolism. It can directly enter the phase 2 metabolism, and conjugated drug is usually inactive because the functionality through which it is showing, it is manifesting the pharmacological response or जो भी biological activity ये show कर रहा है, that is hidden or that is being arrested by conjugation reaction. Now, comparing the phase 1 and phase 2 reactions, enzymes, the type of reaction. The phase 1, the type of reactions are hydrolysis, oxidation, reduction. Whereas in phase 2, there are conjugation reactions. In phase 2, there is increase in hydrophilicity. The second point is increase in hydrophilicity. So as a consequence of phase 1 biotransformation, there can be small increase of hydrophilicity as compared to phase 2. It is a relative increase in the hydrophilicity. Then general mechanism, it exposes, the phase 1 exposes the functional group, and the phase 2, it hides the functional group because through these functional group, there happens the conjugation of some other substances. So polar compounds are added to the functional group via conjugation reaction. Now, what can be the consequences? Phase 1 lead to or result in metabolic activation, and phase 2 facilitates the excretion. Understood? Now, what are the factors affecting the biotransformation of a drug? The one is prior administration of drug or co-administration of other drug or other xenobiotics. Prior administration means if besides having our जो हम drug ले रहे हैं, whatever drug we have to take, before that we have taken some other drug. So there can be certain interactions, drug-drug interaction or xenobiotics interactions. Then diet, then hormonal status, then genetics, then diseases, then age and developmental state, and the functional status of liver and kidney. Though I have already told you that liver is the main site of occurrence of cytochrome P450 enzymes, but kidneys, especially the adrenal glands, also contain some amount of cytochrome P450 enzyme. That's how liver is the major site for metabolic biotransformation of these xenobiotics. Then now move on to the phase 1 reaction proper. So these are the reactions, phase 1 reactions, mainly oxidation. We have oxidation reaction. Then we have reduction reaction, then hydrolysis reaction. They are also called hydroxylation reactions since they introduce or expose a functional group that serve as an active center for sequential conjugation in phase 2 reactions. This hydroxylation or any other functionality addition will act as a hook onto the xenobiotic, or us hook ke through that hook there will be conjugation reaction in phase 2 reactions. So I have one example of oxidation reaction. A large number of foreign substances are destroyed by oxidation in the body. For example, I have just given you the example of this methanol. So you can see it here, oxidation of methyl group containing compounds. So methyl group is oxidized to acid through formation of alcohols and aldehyde. So you know oxidative pathway from alcohol to always oxidation to aldehyde and then jump to acidic group. This is the normal trend from right from alcohol to conversion to the corresponding acid. So methanol, in case of methanol also it happens. Methanol toxicity is because of conversion of methanol to formaldehyde and further to formic acid. Now, next example, you can see it. Similarly, ethanol undergoes oxidation reaction, acetaldehyde, further to acetic acid, which is not very toxic because it is easily excretable out of the body and it is a mild acid. Then benzoyl alcohol, similarly, it turns to benzaldehyde and further to benzoic acid. I told much about the methanol toxicity. I'm just briefing in very short. Methanol has relatively low toxicity. Methanol is metabolized in the liver. In the first step of degradation, methanol converts to formaldehyde via enzyme alcohol dehydrogenation. Transformation of formaldehyde to formic acid via enzyme aldehyde dehydrogenase is faster. So metabolism of formic acid is very slow, thus it often accumulates in the body, which results in metabolic acidosis. The major damage occurs to the optic nerve. Ethanol is given as an antidote. Always ethanol is given to treat the patient suffering from methanol toxicity. Okay? So because it competes with methanol and for the enzyme, it is acting as a like competitor to methanol. So it is given as an antidote since it is a true substrate for alcohol dehydrogenase, and then methanol is spared from getting metabolized. The next example is this is the case of benzaldehyde, how benzaldehyde is converting to benzoic acid. So it is an example of oxidation. Similarly, second type of reactions are more than 70% reactions are of oxidation type. Besides, there can be reduction reaction. I can give some example of like few xenobiotics which contain chloral like CCl3CHO kind of compound which converts to trichloroethanol. So aldehyde to ethanol, it is an example of reduction reaction. And ethanol is more water, it is more hydrophilic, so it can easily be excreted out of the body. So trichloroethanol is excreted after conjugation with D-glucuronic acid as a corresponding glucuronide. Next, reduction. Reduction of nitro compound, para-nitrobenzene to para-aminobenzene. So always the nitro group is converting to amino group. This is also another example of reduction. And amines are very nicely miscible with aqueous system or hydrophilic as compared to nitro groups through hydrogen bonding. Then next type of reactions of phase 1, they are hydrolysis. Certain therapeutic compounds undergo hydrolysis. I just spoke about, this is acetyl salicylic acid or aspirin, what we'll call it. It is an aspirin. Aspirin converts to acetic acid and salicylic acid. And this salicylic acid is actually having the analgesic property. So when we are suffering from some pain, we need to have some aspirin, one dose of aspirin, and you are relieved from the pain because of this metabolite, that is salicylic acid produced in vivo as a consequence of cytochrome P450 biotransformation. Then similarly, atropine turns to tropic acid and tropine. So its pharmacological effect of atropine are because of tropine. Then digitalis, and then you have a procone. These are, most of these molecules have either ether linkage or the ester linkage. So these are prone sites for hydrolysis via enzymatic way. Next is hydrolysis of procane. It's very clear. See, you can see it here. There is a, which type of bond is there? This is a ester bond. This is a ester bond, COO, if it, CH2, CH2N. So N may have some other R. So this COOR, COOR system is there, then it is an ester. So this is the prone site. This carbonyl carbon is a very prone site for attack by the water molecule. So hydrolysis takes place from this side enzymatically. Now, what actually the cytochrome P450 enzyme system is? Let us have brief understanding of these enzymes. It is a huge number of family. It is not one or two enzyme. It is not one or two family. It is a huge family members associated in this group, group of cytochrome P450. So general reactions for the cytochrome P450 reaction is that it always requires one xenobiotic. So RH is some xenobiotic which is having H, which can be replaceable by oxygen, or it can be substituted, or whatever, it can be substituted by some functionality. Then it always requires a molecular presence of oxygen. Oxygen gas it requires, then reducing equivalent in the form of NADPH. So another utility of NADPH is in this xenobiotics biotransformation. What is, can you anyone tells about what can be the source of NADPH? It comes from where? What is the source of NADPH generation? It comes from HMP shunt. Understood? So its another role is in the synthesis of cholesterols and fats and fatty acids. Fatty acid synthesis, maybe it is, it is utilized. So another use of NADPH is in the xenobiotics metabolism. So molecular oxygen, then you want NADPH. Then what kind of bias transformation happens here? R is associated with some functionality. Initially there was only hydrogen, now it is attached with some functional group. Most commonly it is the hydroxyl group, which is more polar, and because of which the xenobiotic can acquire the hydrophilicity. Then water molecule is also produced, and NADPH is now oxidized to NADP. It has given its hydrogen. So itself, it is oxidized. It has reduced the molecular oxygen. And in this reaction, you can see there can be two fate of oxygen. एक तरफ तो oxygen किधर जुड़ रहा है? One atom of oxygen is adding to the xenobiotics as an hydroxyl group. Is it clear? And another oxygen is utilized for formation of water. So the oxygen has two functions. So that's why these enzymes are also known as mixed function oxidases. It manifests the two functions of oxygen. One is it is used as in functionality, and second, it is used in generation of water molecule. So RH above can represent a wide variety of xenobiotics, including the drugs, carcinogens, pesticides, petroleum products, and pollutants. In addition, the endogenous compounds such as certain steroids, eicosanoids, fatty acids, and retinoids are also the substrates. The substrates are generally lipophilic in nature and are rendered more hydrophilic by hydroxylation. But what happened once it's not necessary every time whatever xenobiotics we are inhaling or we are taking as a drug is always lipophilic? Not necessary. If the drug is enough hydrophilic or xenobiotic is enough hydrophilic so that after a certain span of time, it stay in the body, it goes of its own accord. So it will escape either phase 1 or phase 2 reactions biotransformation. It doesn't undergo. So such a type of substances are known as hard xenobiotics. उन xenobiotics को या उन drugs को हम क्या कहते हैं? Hard drug. They don't undergo any biotransformation because there is no need of this kind of conversion. They are enough hydrophilic, they are enough smaller so they can cross through every barrier and they can easily excreted out of the body after small span of time. So the substrates are generally lipophilic and are rendered more hydrophilic by hydroxylation reaction. Hydroxy group क्या है? What is hydroxy? It is more polar as compared to hydrogen. See, for instance, this is RH. Suppose it is a benzene, C6H6. It is quite hydrophilic because इसमें कोई ऐसी functionality नहीं है so that it becomes polar. It is a non-polar substance. But once you are adding it with some hydroxyl group, some other functionality, it can be amine also. So जब कोई functionality लग गई, so because of addition of that functionality, the nature, the chemical and physical property of that molecule are changed. Now it has become more hydrophilic. If you dissolve phenol in the water, it is miscible with the water. और अगर आप एक और functionality add कर दो, if it is not easily miscible, then there is a requirement of one more biotransformation. Biotransformation will result in, it may add up to 2 hydroxy group, it may add up to 3 hydroxy group, depending upon the type of lipophilic bulk. And we have to convert it into the hydrophilic substances so that it can easily be excreted out of the body. So nature has given this quality to us so that the body, the enzymes can decide upon to what extent the biotransformation has to happen so that it can completely converts to the hydrophilic entity. It is not left as such midway. Only one hydroxyl group is added, but the bulk of hydrophobic is very high so that still it is not replaceable or it is not shifting or it's not miscible with the aqueous medium of the blood. So in that condition, the decision, the body's reaction and is that more and more biotransformation and more hydroxylation is required. So instead of 1, there can be 2 and 3 and so forth. Additions of hydroxy group can take place. Now, properties of human cytochrome P450. Much I have talked about the P450. It involves in phase 1 type of metabolism of innumerable xenobiotics. It's not involves the phase 2 metabolism. For phase 2 metabolism, there are different category of enzymes. It is only cytochrome P450 are only concerned with phase 1 biotransformation or metabolism. Keep in mind. Then involved in the metabolism of many endogenous compounds. All are hemoprotein. Heme protein means all these enzymes, the characteristic of these enzymes, that all of them contain a heme ring. Heme, you know, the same ring which is present in myoglobin and the hemoglobin. So exhibit broad substrate specificity and those act on many compounds. Extremely versatile catalysts, perhaps catalyze about 60 type of reactions. Basically, they catalyze reactions involving the introduction of 1 atom of oxygen into the substrate or 1 into the water. So that's why sometimes we also call it as a mixed function oxidase enzyme. Instead of cytochrome P450, another name is mixed function oxidase enzyme. Understood? Liver contains highest amount, but found in most, if not all the tissues. Just a minute. Liver contains the highest amount, but found in most, if not all the tissues, including small intestine, brain, lung, and also in kidneys, adrenal glands, located in a smooth endoplasmic reticulum. In the cell, in the hepatocyte, what is the site? It is packed in the smooth endoplasmic reticulum, or sometime in the mitochondria, especially in the adrenal gland, it lies in the mitochondria. In some cases, their products are mutagenic or carcinogenic. Many have a molecular mass of about 55 kilodalton. Many are inducible. They are inducible enzyme, means normally they are not synthesized all the time, but once some xenobiotic enters the liver, and that induces the type of gene for synthesis of particular type of enzyme. It is not a whole family, it is one member of any one family. They can be 1AB, 1,2B, 1B, 1B1, 1B2, 1B3, etc., or 1A1, 1A2, and so on. So if we talk about the nomenclature, suppose if you are writing 1A1, clear about these xenobiotic enzymes. Suppose it is written 1 B2. So the one designate, it is the first family member. Out of the huge family, it is family number 1. And B means it is a subfamily. B designates the subfamily, and 2 is the, it is the second, it is the second member of that family. Clear to everyone? So the second member of that subfamily. So this is how the nomenclature of the cytochrome P450 enzyme has been given. Similarly, 3A4. Can anyone explain to it? 3 stands for family number 3. A is the subfamily A. 4 is the fourth member of that family. Okay. Next. Many are inhibited by various drugs or their metabolite products, providing another cause of drug interaction. Some exhibit genetic polymorphism, which can result in atypical drug metabolism. I don't want to clear it more right now because you are at very basic level trying to understand the concepts of xenobiotic metabolism. You may be confused. So in the further lecture, I can explain more about what are the xenobiotic interactions, what are the genetic polymorphism, etc. Then, so that's all about the phase 1 biotransformation. So for today's lecture, what we have discussed what are the xenobiotics, what are the fate of xenobiotics in the body, how the body treat them, and what are the cytochrome P450 enzymes. Acha, why nobody asked me what is the meaning of CYT P450? So CYT stands for cytochrome, and cytochromes contains always a heme ring. It is some protein. It is a protein with prosthetic group as a heme. It is cytochrome. Then P for P450 means this is a very peculiar property of all these enzymes, that once these enzymes are exposed to carbon monoxide, and this carbon monoxide adduct is once exposed to our UV spectrum of one of these compounds, so you will always get a strong peak at 450 nanometer under the UV spectrum. So that's how all the members are named as cytochrome P450 enzymes. Could you understand? Carbon monoxide complex, once it is its spectrum is run, so you will get a very peculiar long and very thick peak at 450 nanometer under UV run. So that's all about the cytochrome P450. What are these enzymes? What the raw material they require for their action? What kind of biotransformation under the phase 1 category happen? And what are the consequences? So that's all we have discussed. So overall, in a nutshell, what we call the biotransformations may lead to metabolic activation, may lead to metabolic inactivation, may lead to conversion to harmful product, or may lead to conversion to harmless products. So body is unaware of this. It is only converting the lipophilic entity into something which is more hydrophilic, more polar, so that it can easily be excreted out of the body. So that's all about my today's lecture. If you have any questions and any queries, you can ask me today or after the class. So with this, I'm going to ending up my lecture. Thank you all for listening patiently.